Hello, am I audible? Hello.
Yeah, you're audible.
And is my screen visible?
Yes, it is.
Okay, thank you. Good evening, everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Ayan Maiti. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my fourth live session, and I will discuss some practice problems on week 4 topics. So week 4 topics were SVM and perceptron learning. So I will discuss some problems on these topics. And if you have any questions or queries regarding these topics, please feel free to ask me during this session. Anand Satyamurthy, do you want to say something? You have raised your hand. If you want to say something, you can unmute and ask me. Okay, we will start solving some practice problems, and after that, if you have any questions or doubts, you can ask me. So this is the first question. Consider a Boolean function in 3 variables that returns true if 2 or more variables out of 3 are true and false otherwise. Can this function be implemented using perceptron learning algorithm? So there are 3 variables in this function, and the output is true if 2 or more variables are true, and output is false if 2 or more variables are not true, that is false. So can this function be implemented using perceptron learning algorithm? You can write your answers in the chat. So most of the answers I can see in the chat are yes. So the correct answer is yes. So to find out the answer, we just have to check whether the points are linearly separable or not, because perceptual learning algorithm is a linear classifier. So if the points are linearly separable, then only perceptual learning algorithm will be able to classify the points. So the function is x1, x2, x3, and y is if y is the output. So when at least two of these three variables are true, then y is true, otherwise false. So we can simplify this function, the classifier, like this: if x1, x2, x3 is greater than equals, if x1, x2, x3 is greater than equals to, then y will be true, else y is false. So basically x1 plus x2 plus x3 equals 2. So this is the straight line that classifies the two sets of points or two classes. That's why when the x1 plus x2 plus x3 is greater than equals to, then the y is true, and when this sum is less than 2, then y is false. So that means this is the straight line x1 plus x2 plus x3 equals 2 that linearly classifies the two classes, true and false. So if we can have a linear classifier or a straight line that separates the two sets or two classes, then certainly perceptual learning algorithm will be able to classify them perfectly. So this is how we can check whether perceptual learning algorithm can be used for this task or not. Now question 2. So this is on support vector machines, SVM. For a support vector machine model, let xi be an instance with label yi. If yi beta 0 hat plus xi transpose beta hat is greater than equals 1, where beta 0 and beta are the estimated parameters of the model, then there are four options. Xi is not a support vector, xi is a support vector, xi is either an outlier or a support vector. Depending upon the data points, xi may or may not be a support vector. So this is the condition, and for this point xi comma yi. So given this condition, whether xi is a support vector or not, or if it's an outlier or not, you have to find out. Sreni Bakayat is saying A, VG Satish is saying A. Any other answers? Archa is saying A. Meenakshi is saying A. Harapriya Kaur is saying A and D. Rakhi is saying A, Aditya is saying A. Someone is saying we are not getting audio. Am I audible, right? I am audible, right? Can anyone please let me know if you can hear me? Okay. So the correct answer is option A. Most of you have written the correct answer in the chat. That xi is not a support vector. So to know whether a point is support vector or not, we can use this functional margin. This is also called functional margin. If this is 1, this is the functional margin. If this quantity is 1, then the point is a support vector. If this functional margin value is greater than 1, then the point is not a support vector. So this is the basic condition to check whether.
Hello.
Yes.
Sir, can you tell why option D is not correct?
For this point xi, this condition is already given, so it doesn't depend on other data points anyway whether xi is support vector or not. For support vectors, this condition must hold true. Yi into beta 0 plus xi transpose beta equals 1. It has to be equal to 1 for a support vector. If it is
plus xi transpose beta equal to 1, that statement is not for that other data points, only for this.
The question is only for xi, whether for xi this condition is given, this condition that this functional margin is greater than 1. Now for the point xi, you have to find whether that xi is support vector or not. So it doesn't depend upon other points. For support vectors, this value is equal to 1, and for other points value is greater than 1. So it doesn't depend on other points, because for xi the condition is already given that the functional margin is greater than 1. Aditya is saying for this condition xi can be outlier. Yeah, xi can be an outlier, but the option C is either an outlier or a support vector. So it is certainly not a support vector because the functional margin is greater than 1 for this point. So C is also not true. And now question 3. Suppose we use a linear kernel SVM to build a classifier for a 2-class problem where the training data points are linearly separable. In general, will the classifier trained in this manner be always the same as the classifier trained using perceptron learning algorithm on the same training data? So for a 2-class classification problem, if we use a linear kernel SVM and if we use a perceptron learning algorithm, whether these two classifiers should be exactly same or not. RJ saying B, Srinivaka saying no, VG Satish is saying B, Arijit Sai is saying no, Meenakshi is saying B, Srinivakasan depends on initial weights. Harapriya is saying B. The correct answer is B, that is no. So the two algorithms are SVM and perceptron learning. So the objectives are different in these two algorithms. In SVM, the objective is to maximize the margin, where margin is the distance of the closest point from the straight line or the linear classifier. And in case of perceptron, the objective function is different, that we want to make all the yi values same as the functional discriminator. Sign of the yi should be equal to the sign of the discriminator, that is the objective function in perceptron. So the objective functions are completely different. So as perceptron learning might find a different linear classifier compared to SVM. So the correct option is no. Anand Satyamurthy, you have unmuted your microphone. Do you want to say something? Oh, okay.
Sorry, sir. I'll put you.
Okay. Now question 4. Which of the following is or are true regarding an SVM? So there are three options. For two-dimensional data points, the separating hyperplane learned by a linear SVM will be straight line. Option B is, in theory, a Gaussian kernel SVM can model any complex separating hyperplane. And option C is, overfitting in SVM is a function of number of support vectors. Lakshmi is saying A and C. Arijit Sai is saying all. So more than one options may be correct in this case. Raki is saying here, Deepak is saying all are correct. Srini is saying all. Meenakshi is saying A only. Shruti is saying all. Penta Shravani is saying all. So the correct answers are all three options. So the first option says that for two-dimensional data points, the separating hyperplane learned by a linear SVM will be a straight line. So this is for two-dimensional data points, it is certainly true that the hyperplane would be a straight line between the two sets of points or two classes. SVM, the linear SVM always learns a straight line. Option B is, in theory, a Gaussian kernel SVM can model any complex separating hyperplane. This is also true. Gaussian kernel theoretically can model any kind of complex hyperplane. So that's why in many of the problems where points are not linearly separable, Gaussian kernel is used. Whether we need if we don't know whether we need a quadratic polynomial or a linear polynomial, we don't know. In that case, we can safely use Gaussian kernel, and it would be able to model any kind of polynomial classifier that will be needed for that data set. So this is also true. And third option is overfitting in SVM is a function of number of support vectors. This is true because if if the SVM is finding out too many support vectors, that means the model is too much complex, which might not be necessary. So there will be too much variance in the data if we have too many support vectors, and if we simplify the model, number of support vectors should be lesser, and which might be better for the test data. So all three options are correct here. Consider the one-dimensional data set. This is the data set x and y, and x is the feature and y is the output. State true or false. The statement is that the dataset becomes linearly separable after using the basis expansion with the basis function phi x equals 1 and x cube. So if we use this basis function on this dataset, whether the points will be linearly separable or not. Are appraising B, which is false. Meenakshi is saying false. Lakshmi is saying false, and Dr. Abhishek Mishra is saying false. Shruti is also saying false. Shreni Bhagat is saying B, which is false. So for this question, for every point you have to compute this phi x basis expansion for each of the points. So if we compute phi x for the first point, x is minus 1, so for first point it would be 1 comma minus 1. Minus 1 whole cube is minus 1, so it would be 1 comma minus 1. For the second point, which is 0, so it would be 1 comma 0, and for the third point it would be 1 comma 8. 2 cube is 8, so 1 comma 8. So these are the three two-dimensional points that we have, and we have the corresponding y values. So we just have to plot these points and see whether the points are linearly separable or not. So the first point is 1 comma minus 1, so it will be somewhere here, and y value is plus 1 for this, so I am writing plus 1. Second point is 1 comma 0, so second point will be here, and its level is minus 1, so I am writing minus 1. And the third point is 1 comma 8, so it will be somewhere here, and its level is plus 1. So this is one plus 1 point, this is another plus 1 point, and between these 2 points we have this minus 1 point. So the points are not linearly separable, so we cannot draw a straight line which will separate these 3 points. So the answer would be false, that the points are not linearly separable after this basis expansion. Now question 6, state whether true or false. After training an
Can you go back to the previous slide?
Yes. Do you have any question in this slide?
Okay, thank you.
State whether true or false. After training in SVM, we discard all the examples which are not support vectors. So basically we only keep the support vectors and discard all the other points which are not support vector. Can we still classify new examples? If a new example is given, can we still classify the new point? So all the answers in the chat are true. So the correct answer is true, that if we only keep the support vector points, we will be able to classify new examples, because for the to construct the linear classifier or the straight line, we just need the support vector points, and the coefficients or the weights are related to only the support vector points, so we don't need all the other points. We can discard all the other points, and we will still be able to classify new examples in case of SVM. Question 7. Below are the labeled instances of two classes. So these dots and crosses are given to represent two classes, and hand-drawn decision boundaries are also given. So these blue lines represent the decision boundaries. Which of the following figure demonstrates overfitting of the training data? Hazratvi Yadwarde is saying C, Aditya is saying C, Archa is saying C, Rakhi, Viji, Srini all are saying C. Meenakshi is saying C, Dr. Abhishek Mishra saying C, Shohini Banerjee is saying C. Ariva Jhagan is saying C, Akhil is saying C. Orijit Sai is saying A. And the correct answer is option C. The first, you have to find out in the figure in which the classifier is demonstrating overfitting. So for the first case, the option A, this is a straight line, and some points are misclassified. We can see that some points are misclassified. In second case, we can see that this decision boundary is no more a straight line, but it is misclassifying 2 points here. And in the third case, we can see that it is this decision boundary is too much complex, and it is trying to fit the training data very closely. So that's why the decision boundary has become very complex. So this is that's why option C is a case of overfitting, that it tries to fit the training data too much, and so in this process it might happen that in the test data its accuracy might not be very good, because it is getting overfitted to the training data too much. It's also trying to model the noise and outlier points.
Sir, what will happen if we increase the dimension? Means if we go to like higher dimensions?
Yeah, so
all the three examples means the same example only. If we increase the dimension, what will happen?
If we increase the dimension, the decision boundaries would also change. So decision boundaries, we have to draw the decision boundaries again for differently for different figures, because it is 2 dimension. So for then again we have to run the algorithm again and find out the decision boundaries. Then only we will be able to say whether it will overfit or not.
So my question is basically like underfitting, overfitting. No, there was one question in assignment, but I couldn't find anywhere like feature. If we increase number of features, or if we increase the points, what will happen to the? Means it will become bias and variance. What will be the effect?
Yeah, so in that case, you have to find out whether you are making your model too much complex or not. So if the model is too much complex, then it is much more prone to overfitting. So that's why we try to make the model simple features we prefer. If we construct too many features, then the model might be overfitting.
So then in this case, options, this option, no, this is which is the last option. There it is, variance is lower, but the bias is high. Like it's like that.
No, bias is low, variance is high. For overfitting, variance should be high.
Oh, yes.
Because for very small changes, it is changing the output. So that's why variance is high, but bias should be low, because it is trying to completely fit the training data. So bias, which is basically the error, that will be very low.
Okay, sir. Okay.
Now question 8. A hypothetical SVM model has the following values of the Lagrangian multipliers and support vectors. So these alpha values are Lagrangian multiplier values, and the support vector points are given. So 3-dimensional points. So each support vector contains 3 dimensions here, and the y values are also given. So you have to find out the coefficient of the SVM linear separator for this, which is beta, represented by beta, given this support vector points and the corresponding alpha values and also the y values for the support vector points. You have to find out the coefficient beta in SVM without the intercept term, only the beta 1, beta 2, these coefficients, not the beta 0 coefficient. For that computation is different. Srini Bhagati Singh 1, minus 2, 0.5. Orijit Sai is saying 2, minus 2, minus 0.5. Deepak Srivastava is also saying the same answer, 2, minus 2, 0.5 he is saying, not minus 0.5. VG Satish Singh 2, minus 2, minus 0.05. Sreni is saying 2, minus 2, minus 0.5. Same answer. But Aditya is saying 1, 1.5, minus 1. Lakshmi is saying 0, minus 2, minus 0.5. So many different answers I'm getting in the chat. Meenakshi is saying 1, 1.5, minus 1. Harapriya is saying 0, 2, minus 5. NS is saying 2, minus 2, minus 0.5. Rakhi says minus 0.25, 0.25, 5. In the chat all the answers are different. So to compute this coefficient beta, the formula for coefficient beta is alpha I xi yi. So this is the formula. Beta is equal to summation I equals 1 to n. N is the number of support vector points. Alpha I xi yi. So all these three information are already given. Alpha support vector points, these are, so the support vector point represents as xi points, and yi values are also given here. So we just have to multiply them and sum over all the support vector points. So if we compute this, it would be 1 into 1 minus 1 1 into plus, so into 1 plus 0.5 into 0 comma 2 comma minus 1 into minus 1, and then plus 1 into minus 1 comma 0 comma 2 into minus 1. Now if we have to add all these things up, so first point is 1 comma minus 1 comma 1, second term is minus 0.5 comma, so this is minus 1 comma plus 1, so 0.5 plus, and third term will be minus 1 comma 0 comma minus 2. Now we have to add these three terms. So first term would be 0 minus 0.5. I might have missed something here. Zero 2 comma minus 1.
So second point it will be 0, sir, not minus 5.
Oh, this one, yeah, this would be 0,
0, yes.
And third
and
point
this one would be plus 1, yeah,
plus
so negative negative, it would be plus 1. Then now I think it would be right. So first term is 2 here, second term will be minus 1 minus 2, 2 so minus 2, and third one is 1 1.5 minus 2, so minus 0.5. So 2 comma minus 2 comma minus 0.5, I think, yes, 2 comma minus 2 comma minus 0.5. This is the correct answer, and many of you have written the correct answer in the chat. Yeah, many of you have written 2 minus 2 minus 0.5. So basically you have to multiply this alpha I support vector point xi and yi, and then sum over all the three support vector points. That will give you this three-dimensional coefficient beta. Is there any doubt in this question? Many of you have written wrong answer in the chat. Most of you have written wrong answer in the chat. Is there any doubt in this question? Okay, then question 9. Suppose we have 4 training examples in 2 dimensions. Positive examples are x1 and x2. So x1 is 0, 0, x2 is 2, 2. These are 2 positive examples, and we have 2 negative examples, x3 and x4. x3 is h, 1 and x4 is 0, 3. But h is between 0 to 3. Then how large can h be so that the training points are still linearly separable? So we want the points to be the positive points and negative points to be linearly separable. Then what should be the maximum value of h? Basically, the maximum value. What should be the maximum value of h?
Yes, sir, less than 1. It is a repeated question. In previous problem solving examples, this question has been completed.
Oh, okay. Yeah, two of you have already written less than 1. Okay, so I will just explain how this can be done, as this has already been discussed in previous live session. So
Sir, by plotting graph, by plotting 2D graph.
yes, so we have to plot these 4 points. So this is the point x1, and here it will be point x2. So these are two positive examples, and x3 h comma 1, we don't know what is the value of h. It is between, h is between 0 to 3, so it can be between in this range, anywhere in this range 0 to 3, if this is the x equals 3 line. So h can be anything between 0 to 3, and y component is 1, so it will be somewhere. If this is y equals 1, then the x3 point can be anywhere in this straight line. This is for x3, and x4 is 0 comma 3, 0 comma 3, so it will be somewhere here, x3. So these 2 points are of same class, that is positive class. So x3 this one is x4, so x3 has to be in this region, that is the upper left of the straight line joining x1 and x2. x3 has to be in this region, so that x3 and x4 can be linearly separated from x1 and x2. So for that we just have to find out this point. This is the maximum value that h can take for x3, and it can take any value lesser than this, but not more than this. If it takes value more than this, then if x3 is here, the x3 and x4 are not linearly separable from x1 and x2, and this point is h equals 1 here. So this is actually, so it should be written x equals 1, and value of h should be less than that, anywhere in this region. So h has to be less than 1. If h is less than 1, then x3 and x4 can be linearly separated from x1 and x2. So is there any doubt in this question, as it has already been solved in a previous live session? So if someone of you did not join that and you can't understand, then you can ask me.
Can you explain once again the question number 9?
So in question 9, the x1 and x2, these are the 2 points. These 2 points are positive examples, x1, x2, and x3, x4 are negative examples. x3 is h comma 1. So this value of h is not known, and you have to find out what is the what can be the maximum value of h. So I have to draw it again then. So x1 is here. If we plot it on two-dimensional plane, x2 would be here, x4 is here, but for x3 we don't know the value of h. H can be between 0 y component is 1, so that means the point x3 would be on this straight line from this is the x equals 3, then x3 can be anywhere in this region on this straight line. Value of h can be from 0 to 3, it is already given, so it can be here, and these 2 points are positive points, x4 and x3 are negative points. So x3 would be, if we join these 2 positive points x1 and x2, x3 can be anywhere in this region, then x3 and x4, these two negative points are linearly separable from x1 and x2. If x3 is here or x3 is here, then x4 and x3, these two negative points cannot be separated from x1 and x2 linearly. So x3 has to be in this region. In this region x3 can be, that is the upper left side of this line joining x1 and x2, and the maximum value that in that region h can take is here. Here if we just find out the point where this straight line and this line segment meets, it's this is x equals 1, so h has to be less than 1. If h is less than 1, then this x3 point is here or here or here, like this. In that case, these two points are linearly separable. These two classes are linearly separable.
Okay. Thank you.
Question 10. A kernel function kx comma z measures the similarity between two instances x and z in a transformed space. For a feature transform x to phi x, that is also known as basis transformation or basis expansion, the kernel function kx comma z is phi x dot phi z. So this is not product, this is not simple multiplication, this is dot product. Consider the two-dimensional data points x equals x1 comma x2. For the kernel function kx comma z, 1 plus x dot z, so this is also a dot product, x dot z. What is the corresponding feature transformation? Phi x. So if this is the kernel that we are using, what is the feature transformation from x to phi x? I have not received any answer in the chat, so this question might be a little difficult. So kx comma z equals 1 plus x dot z, and x is given that it is a two-dimensional input vector, x equals x1 plus comma x2. So we can this is dot product x dot z. So similarly z would also be z1 comma z2. So x1 comma x2 dot z1 comma z2, so it will be 1 plus x1 into x1 into z1 plus x2 into z2. So after dot product we get this. This is the kernel of x comma z 1 plus x1 into z1 plus x2 into z2. So we can so kernel x comma z equals 1 plus x1 z1 plus x2 z2. We can decompose this term 1 plus x1 z1 plus x2 z2 as 1 plus so we will decompose this term into two different factors, and each factor will contain either x or z, so that we will get this transformation from x to phi x or z to phi z. So we can write it like this. 1 comma x2 dot product 1 z1 z2. So we can certainly decompose this term as this, because the dot product of this second term will come out to be the first term. So this 1 x x2, this is the feature transform from x to phi x. So this is the phi x, 1 x1 x2. So this is how we are expanding the basis. This is all basis expansion from x1 x2 we go to 1 x1 x2. So this is the correct answer, B. Phi x equals 1 x1 x2. So basically you have to
Can you repeat?
this is a dot product x dot z. So you have to expand this term 1 plus xz. X is x1 x2, this is a vector. Z is also a vector, is z1 z2 similarly. So you will expand this x dot z. So you will get this dot product 1 plus x1 z1 plus x2 z2. Now you have to decompose this whole kernel into two terms. Each term will contain only x or z terms. Otherwise we will not get this transformation for x only and z only. So we can transform, we can factor this into two terms, 1 x1 x2 and 1 z1 z2. This is also a dot product between these two. If we compute this dot product, we will get this 1 plus x1 z1 plus x2 z2. And this 1 x1 x2, this is a kernel representation, and for x, and this is the 1 z1 z2, this is the kernel representation for z. So this is the feature transform for x and z. So
So x1 z2, it is not possible in the dot function.
which one?
x1 z2 after multiplication.
x1 z1 x2 z2 have written.
x1 z2, it will not be there.
No, I don't want that, because this was the original kernel, isn't it? 1 plus this one, the 1 plus x1 z1 plus x2 z2 I need. I don't need x1 z2 or x2 z1. That's why I am using dot product. Only with dot product I will get this x1 z1 and x2 z2 only. I will not get the other two terms, x2 z1 and x1 z2. I don't want those two terms, because I want to compute this one, which contains only x1 z1 and x2 z2.
Okay.
Yeah, so these were the practice problems I wanted to discuss in this live session. Now if you have any other questions or queries, you can ask me.
Sir, I missed the first question. Very first question.
Yeah, the recording will be uploaded in YouTube, and also the slides will be uploaded, so we will get all the links there. First one was easy. So x1 x2 x3, three variables, and output is y, and y output is true only if two or more variables are true, and output is false if two or more variables are not true. So we can simply compute this condition. This is the condition for y to be true, using the statements that are written in the question, that if x1 plus x2 plus x3 is greater than or equals to, then y will be true, otherwise y is false. So that means this is the linear discriminator, x1 plus x2 plus x3 equals to, this is the decision boundary, and if x1 plus x2 plus x3 is greater than or equals to, then y is true. If it is less than true, then it is false. That means there is a linear discriminator or linear decision boundary that we can get. So if the points are linearly separable, certainly perceptron learning algorithm can be used. So that was the question, whether perceptron can be used or not.
Hello, sir.
Yes.
Sir, can you go to question number 8, week 4? That question, I just want to know it is based upon the complexity or performance. Can you tell that?
The question is given in the assignment 4.
Yes, week 4.
I have not seen that, and it will be better if you ask in the discussion forum if you have any doubts regarding assignment that has whose deadline is not over yet. So if you have any doubts, you can ask in the discussion forum. The TAs would be able to answer your questions in a better way.
No, that is regarding SBM, na? That's what you are explaining SBM. That's what I'm asking.
I cannot discuss about the questions. The deadline is not over yet in that for that assignment.
Okay.
Sir, I can ask a question.
Yes.
Sir, thanks for giving. I am new to this field. I am above 50 years and I am learning this one. Can you just suggest me how to learn this one? I am starting from the receptron. I am able to understand some of the things what you discussed. Can you explain me how to proceed of this machine learning?
You have started from week 4.
Correct.
It would be better if you start from the beginning, otherwise things might become difficult to understand for you. There are many things that have been taught in the first 3 weeks, so you might not be able to understand all the subsequent topics that will be covered in next few weeks.
Okay. I'm feeling this course for this very high level, and it's not for the people who are not in the to understand this one. Is you have any book for this reference to go through this things?
Books have been recommended in the video lectures. What was the name of that book? In the video lectures, the books, and also in the course web page, the recommended books are given. I don't exactly recall what was that name of that book.
Hasty, Shibrani Hasty.
What was that book?
So Hasty actually elements of analysis.
Yeah, elements of
Shibarini and Hasty.
Yeah, in the course web page, the book name of the book is given. 1 or 2 books are given there, so you can find. I mean, the course materials are also derived from those textbooks. Those textbooks are also quite high level, so if you want to go through those, you can.
Thank you very much.
Sir, one doubt, sklearn, can you just brief about, because one question is given about solving the given question using sklearn.
Yeah.
So we have to make a program in sklearn for SVM.
Yes.
And that too, it is given like it is higher order polynomial degree 3, and
so you don't have to do much. sklearn will do everything for you. You just have to import scikit-learn in Python, and the support vector classifier. I think SVC is the name of the function in sklearn for support vector machine classifier. So that function is already there. You just have to input those parameters and the data set to it. The C value is given to you in the question, and
yes, so C and gamma both are given. So only problem here, what is happening is like we have only X, and normally whatever program we have made or we have found in internet, it is like X1, X2. So 2 features are there. Here only
no, I mean there can be 100 features. That doesn't matter. These scikit-learn SVM can take any number of features. That is not a problem.
Sir, here actually the features are less because it is asking array when we are making. No, so with the array it is telling it has
No,
to
you have to reshape numpy array. You can get all those things in the internet. You have to reshape the numpy array so that each data point contains only one value. Only one feature is there. Each data point will contain only one value. One row will contain only one point, but it will not be a vector. It has to be a 2-dimensional array. So
Yes, yes.
shape will be like n comma 1, not just n length vector. It cannot be an n length vector to the sklearn package. You have to shape it like a 2D array, otherwise it will not take. So you just have to reshape it.
Okay, sir. Okay, we'll try.
Hmm. Okay, if there are no other questions or queries, then we can end this meeting here.
Okay, sir.
Thank you, everyone.
Thank you, sir.